Section 11.4 is on the cross product of two vectors in space. The definition of a cross product of two vectors in space is given here. Vector u has components u1, u2, and u3. Vector v has components v1, v2, and v3. The cross product of u and v is another vector u cross v that uses this formula. A convenient way to calculate u cross v is to use the following determinant form with cofactor expansion. What you do is you create a 3 by 3 matrix where I, J, K are the headings and the components of u and v are the second and third rows. What this cofactor expansion is simply starting with column I, covering that up, and covering up the row, and you're left with these four remaining values that form a smaller determinant, a smaller matrix. That's going to be the determinant of that smaller matrix is going to be your first component of the cross product vector. Now cover up the column J, and you're left with those four numbers. The determinant of those four numbers is used in the second component of the cross product vectors, but it's the opposite. And then finally cover up the K column, and you're left with these four components. The determinant of that smaller matrix is the third component in your cross product. The way you find a cross product, for example, the first one, you multiply across, and subtract the results. Again, the second one, you multiply across here, subtract the result, and the middle middle component you're going to make negative. For the last determinant, you multiply across u1 and v2, multiply across here, u2 and v1, and subtract. That's your third component for the cross product. Here's an example where we're given vector u and vector v. Find each of the following. U cross v. The cross product of u and v for part A is found by setting up a matrix using the coefficients of the ijk in both the u and v vectors and setting up a matrix. We cover up the I column and the result is this smaller matrix, a 2 by 2 matrix. Cover up the J column and put those values in that matrix. Cover up the K column and use those four numbers in the third matrix. We're going to multiply across here, and subtract the results. To get, when you multiply -2 and -2, you get +4, and 1 times 1 is 1. 4 minus 1 is the first component. The second component is always the opposite. Multiply across here, 1 times -2, and 1 times 3. Subtract -2 minus 3. And then finally the last determinant, 1 times 1, and 3 times -2 is -6. 1 minus a -6 gives you a 1 plus 6. That's simplified to 3i plus 5j plus 7k. Here's another example, v cross u. Start with the v vector and then the u vector. We set up the matrix using the ijk as the first row, and then vector v and vector u. Cover up the I column to get these four numbers in the first matrix. Cover up the j column and cover up the k column to get the remaining two smaller matrices. Find the determinants, and the result is -3i minus 5j minus 7k. Now, if you recall from the previous slide, this is a similar result, but all of the components are opposite. That happens when you reverse the order of the cross product of two vectors. You end up with opposite vectors. Here's another example of finding the cross product. Suppose we're given vector u, which has components 3i plus 5j, and vector v that is equal to 2i plus 3j minus 2k. Let's find each of the following. For part A, let's find a new vector w, which is u cross v. Let's set up a matrix. In fact, I actually do an even more abbreviated shortcut of setting up matrix U, which has components 3, 5, there's no k, so we're going to put a 0 there, and vector v with components 2, 3, and negative 2. Then the u cross v is a new vector where we cover up that I column here and then find the determinant of the remaining 4 components. We're going to do 5 times negative 2 to get negative 10 minus 3 times 0, which is 0. Our middle component is going to be the opposite of the determinant of the remaining 4 when you cover up that j column. Multiply 3 and negative 2 to get negative 6 minus 2 times 0 minus 0. And then our last term, we cover up that k column and find the determinant of the remaining 4 components. 3 times 3 is 9, and 5 times 2 is 10, 9 minus 10. When we simplify the results, I'm using the component form of a vector, but you can also use the ijk form of a vector to get the result of negative 10 as the first component, positive 6, and negative 1. Now for part B and C and D, actually you want to find the angle between U and V, the angle between U and W, and the angle between V and W. Now recall that the cosine of the angle is equal to the dot product in the numerator divided by the magnitudes of each of the individual vectors. For part B, we want to find the angle between U and V. Okay, so the angle between U and V will equal the cosine theta would equal the dot product of U and V. Recall that to find the dot product, you multiply the corresponding components and add the result together. 3 times 2 is 6. 5 times 3 is 15. And 0 times negative 2 is 0. That's our dot product. Simplify that in the numerator. Find the magnitude of vector u. That's going to be 3 squared plus 5 squared, the square root of all that. So 3 squared plus 5 squared. And then the square root of vector v would, the magnitude of vector v is the square root of 2 squared plus 3 squared plus a negative 2 squared. Okay, now take a minute to simplify that and then find the inverse cosine to solve for angle theta. So theta would equal, you end up with a numerator of 21, and this is square root of 34, square root of 17. Use a calculator to find that the angle is approximately 29.1 degrees. In radians, that is approximately 0.51 radians. Let's find the angle between U and W. All right, so the angle between U and W, we're going to use the cosine of the angle theta. In the numerator, we're going to find the dot product of U and W. So to find that dot product, we're going to multiply the corresponding components. It's going to be 3 times negative 10, which is negative 30, plus 5 times 6, which is 30, plus 0 times negative 1, that's 0. Now before I even get to the rest here, notice that the numerator is equal to 0. So the cosine of theta equals 0. That means our angle theta must equal pi over 2. We say that those are orthogonal. So the angle between U and W is 90 degrees. Let's find the angle between V and W. Now the cosine of the angle theta between V and W is the dot product of V and W. Now V, we're going to use the V vector along with this cross product U plus U cross V vector and find the dot product in the numerator. 2 times negative 10 is negative 20. 3 times 6 is 18 plus 18, and negative 2 times negative 1 is a positive 2. And then in the denominator we would divide by the magnitudes. Now before I even get that far, I can see that the numerator is equal to 0. Since the numerator equals 0, the cosine has to equal 0, and that happens when the angle is pi over 2.